Um, in following the Act of Union in 1800, the government in London wanted a link between London and Dublin. And the obvious route was, obviously they were crossing from Holyhead, so they needed a good road link from London to Holyhead. And Telford, amongst others, well, he was the main contributor. He was given the task of constructing that link. Telford was quite a man, along with people like Brunel. I won't go into favouritism, but he was quite a guy. He was a Scot born in Ayrshire, and you can see one of his structures behind him in the photograph there. That is the viaduct at Broncysylltu, which carries the Llangollen Canal 100 foot above the River Dee. They reckon that he was involved with building over 1,000 bridges, a lot of which were in Scotland, and he was into canals and harbours and buildings and everything. There were roads at the time, but all the way along, but they were poor condition, and Telford came up with a road design and linked them all together. And if you look at this sketch, the top bit shows what is basically what we use today, in that you've got a sub base with a base course and a wearing course. But an important feature of this road is the fact that it's cambered and you have a ditch either side, so all the water would run off. All the previous roads were badly rutted with wagons and stuff, and in winter were covered in mud, and in the summer would be very dusty. Now the bottom bit of the drawing shows the gangs actually working, and you can see this chap here, he's actually got a middle gauge, so they were into QA, quality assurance, then, and at that time everything was labour intensive, so they must have had hundreds of people working all the way along the A5. And on this picture you've got men working, but in fact in certain places they used to whole families. The father would break up the big rocks, whereas the wife and the children would break up the smaller stones for the base and the wearing course. Better than working down the pits, I suppose, for kids and under looms and stuff. That's what they did in those days. The biggest task Telford had, was when he came to North Wales. The first bit was relatively easy. If he threw plenty of bodies at it, then you could construct the road. But when he came to North Wales, you had the mountains to cope with, and the biggest factor of all was the Menai Strait, which crosses into, which is between Anglesey and the mainland. And how he coped with that, he built the Menai Bridge, the Menai Suspension Bridge, which at the time was the tallest and longest suspension bridge in the world. Now, he had several constraints given to him by the Navy, because the strait was such a busy waterway. They had to keep it clear, and they also had to have a 100-foot clearance above high water, so that ships could pass underneath. Telford was quite fortunate, and in parts the strait is quite wide, but he at what is now the town of Menai Bridge, and near there was the narrowest spot, and it was narrow because there was rock on either side, and that rock actually gave him the height. So it was an ideal site to construct his bridge. And that's all I'm going to say about the Menai Bridge. Now that was completed in 1826. It actually took best part of 6 years, or just over 6 years, to be built. Now, during that time, technology was improving and galloping ahead, as was industry. And by the 1840s, train transport was coming to be a viable option. And rather than going in a stagecoach all the way from London to Holyhead, people thought it would be a good idea and more comfortable and quicker to use the train. So that's what they did. They got a rail link, but then they had the same problem in that they had to cross the Menai Strait. Now, Telford had pinched the best site, and the task was given to Robert Stephenson to build his bridge for the railway across the straits. They did consider one option of using one of the lanes on the Menai Bridge, but it was not considered a good idea because suspension bridges are not very good for railways because of the movement involved. So they decided they had to go and build another bridge, and this is what Stephenson came up with. Again, this was a major innovation at the time. It was known locally as the Tube, but the proper name is Britannia Bridge. The stone is for the towers were actually built by a chap called John Hemingway, and all the stone was fairly local, and it came from Penmon Quarry, which, if you know Anglesey, it's just on the eastern end of the Menai Strait, just round the corner on the southeast end of Anglesey. There's an island there, Puffin Island, but on the mainland, on the island itself, there's the quarry, and that same stone was used for Menai Bridge as well as for this one. You could say it was convenient because what they had to do was just to load it on big boats or small ships, whatever you want to call them, and bring them down the straits. Sounds easy, but at that time they didn't have much steam power for the boats, and the straits is quite precarious, and they actually lost quite a few of the boats, and people to this day, divers, find blocks of stone at the bottom of the straits. Now, if you just notice the towers here, the height of the towers, and if you notice also the grooves in the towers, I'll refer to them later, but if you just notice them for now. Stephenson had the same constraints on him in that he could not block the main waterway, and he had to maintain his that 100-foot height above the they wanted a clearance above high water. So this is what he came up with. As I said, you might say, hold on, that tower, what they call the Britannia Tower, is actually in the middle of the straits. Yes, it is, but it's actually on a rock that was there conveniently, which was called Britannia Rock, and the main waterway, the throughway, is between these two towers. That's the Britannia Tower and the Land Tower. The Tube was innovative, as I said before, and this wasn't quite the first one. They had a trial run at Conwy, which is a few miles to the east of Bangor, and they built one there, but it was much shorter span and not a great height above the river, and that tube is in fact still there, and the trains still run through it. The principle is straightforward, and I hold workshops with children and with school children, and how I explain the tube is that I show them a piece of paper, shake it about, and it's obviously no strength at all. If you roll it into a tube, then it is considerably much stronger, and that is basically the principle of the tube. This is the forerunner of what we use a lot now as the box girder structure, which is used extensively for bridges and the like. There have been teething problems with those, but because of the time, we can't go into those into that at the moment. You'll see you've got a basic box, but they were also concerned about the strength of it, and buckling was a worry, so they put all these other smaller boxes, if you like, on the top to give it additional strength against buckling, and you had the same at the bottom to give you the tensile strength. And people actually used to go in there on what is a glorified board on wheels, a skateboard effectively, and we've got one of them in the museum, and examine those boxes, just crawl on their back on this little skateboard. I wouldn't fancy it anyway. Now, Stephenson gets all the glory for or claimed all the glory for the design of the bridge, which is sad really, because there were two other people involved. One was William Fairbairn, who was a shipbuilder on the banks of the Thames in Millwall, and another chap called Hodgkinson. Now, Hodgkinson was a mathematician, and the basic idea of the box is by William Fairbairn, and he did a lot of work on it. Sadly, at a meeting in the Civils, Stephenson claimed all the glory for himself and did not acknowledge the work done by the other two at all. And obviously they fell out about it now. That is a considerable shame. Stephenson did a lot of work, and it should be appreciated, but as I keep saying, it's very sad that he did not acknowledge the contribution of these other two. As I said, Fairbairn was a shipbuilder, and he actually brought his boilermakers up from Millwall, and they constructed the box. And as you can see, it's riveted and looks very much in the same way they would have built ships at that time. You saw before they have actually got 5 towers on the bridge: the Abutment Towers, the Land Tower, and Britannia Tower, and then they've got the Land Tower the other side and the Abutment Tower. Now, between the Abutment Tower and the Land Tower, they could actually build the tube in situ. They'd have scaffolding, and the tube was built across. So that was relatively straightforward. The biggest job was constructing the tubes between the Land Tower and Britannia Tower at that end. How they managed that: on the mainland side, just to the west of where the bridge is, they built this platform and worked out very carefully the levels and constructed the tube on site. And you see these chimneys here, they would be for heating the rivets and that sort of thing. The main span, the over the stream is 140 metres long. That's 460 feet, whereas the shorter span is 70 metres long. And the longest span tube, which weighed about 1,600 tons. So they were able to construct it on land, but they had to get it then into position. Now, how they managed that? I mentioned before that they were, I'll just go back and touch actually, they were very careful in working out, they had to be very careful in working out the level, and they had pontoons which at high tide they flooded and then floated underneath the tube, then pumped them out, pumped all the water out, and that raised the tube. So they were then able to float them out to position. They didn't have to go very far. Now it shows here there's 2 pontoons. Now I've heard somewhere else that they actually had 4, which makes more sense, because if you see the width of that, that's a fair old span on the support, but that's not really a major issue. I suppose this is a bit of artistic license. I mentioned before the grooves, and you can see they're here again. What they did, they brought the tube into position and at a slight diagonal, and then pushed that end, the middle end, into the groove in Britannia Tower. Now on the land tower side, you can see it's actually, the side is corbelled, so it's an opening. Then they were able to swing the landward side end of the tube into position and then packed underneath it. They had to be pretty sharp in doing all this, because they would only have a lull of something like 45 minutes, an hour at the most, a lull of slack water. And as soon as they were able to pack underneath, then they would flood the pontoons again and take them away. There is, well, what happened actually when they did the first, took the first tube into position, they didn't quite get the timing right, and they'd anchored they were a bit too soon, and they'd anchored the tube to a point on the mainland, and the current was still quite strong, and it pulled the anchor out. There were a lot of people on the side, thousands of people apparently, watching this, and some bright chap in control got a hold of the rope and told all the people on land to grab the rope, and somehow they were able to hang on to the tube and it didn't and control it. Now the mind boggles as to what could have happened had they not been able to control it. How many people could have drowned, I wouldn't like to guess, and getting the tube back into position again would have been a major problem. With the tube in position within the grooves, they obviously had to then pull them up. And how they did that, they had hydraulic winches on the top, powered by steam, and they had chains on either end, and they would pull the tube up at 6 foot at a time. Now remember this, these weigh 1,600 tons, so they would pull them up slowly, 6 foot up to 6 foot, and as they went along they would pack underneath with pieces of timber. Now and do that all along until they got to the top, and you see these beams. Once they got to the top, they would just push the beams in and just lower the tube back on to rest on the beam. Now they did have an accident actually one of the winches, or the cylinders of one of the winches, blew and the tube dropped. It was something like 8 inches, which doesn't sound like much, but it actually caused a 6-month delay and 1 person was killed. This lump of iron is actually on the access down to the bridge, and it is the base of the cylinder that blew, and you can see the thickness of it from there to there, and this is what blew. So you can imagine what sort of pressure was involved. And if you're ever around, you can and go to the bridge, you can see this. It's there as you go down. This is another photograph of the bridge taken from the Anglesey side, and you can see the grooves there and the corbelling on the mainland. On the land towers has been filled up, so you've got the grooves now. Now you had 4 spans, and you had a total of 4 spans on each side, but you also had two tubes, although it only looks as if you've got 1 there. That's actually a wooden canopy over, so it looks like the one. So in total you would have had, there were 8 tubes, 2 of the long ones and 4 of the long ones and 4 of the smaller ones. And you can see the famous lions on, say this is the Anglesey side, which is still there. This is just a photograph taken at the end of the 19th century, early 20th, I would imagine, showing a train coming through. This is the mainland side. You can see the lions there. And this is the same position taken, I would guess, 1920s, 30s, something like that. This is a close-up of one of the lions. They weigh about 30 tons each, and they're actually made up of 11 different pieces. They are still at rail level and cannot be seen from what is now, you've got the roadway on top, so it's a shame to an extent, but you can still see them from the railway, or you can walk down and see them. As you can see on the date there, on the 23rd of May 1970, there was a fire. There were some schoolboys looking for, well, bird's nests, so they say, and they entered the tubes on the landward side, on the mainland side, and lit some paper to see, well, just to be able to see. And some of this paper dropped onto the floor of the tube, and where there was some debris, and it caught fire, and with a funneling effect through the tube, the fire just ran through, and the following day they couldn't do anything with it. They just had to let it burn itself out. There was a problem with access down. They couldn't get water to it, and this is what you had on the following day. The tube, because of this is the span on the Anglesey side, by the way, of the it had actually moved something by about a metre in the middle there, and it was pretty unsafe. They were very concerned about it, obviously, and it caused major problems in that it cut the link, the railway link, and which was the link to Ireland, which was by this time used a lot for container traffic as well as passengers going to Ireland. So they had a major problem, the first of which was to actually how to get the tube down. So they had a good think about it, and how the first thing they did, because of their concern about the safety, they got the Royal Engineers in, and they built a temporary structure by the towers to support the bridge. They then had, fortunately, there's never an off-the-shelf design, but there was a very similar design for a bridge in South Africa, and they were able to adapt that very quickly. And they put this steel arch in. The arches were constructed at Bellinhelly, which is in Norwich, just a few miles, in an old slate dock up there, and they were able to float them down, as you can see one on there, and they were able to use the tube. In fact, they started from either side, and then once they had the support on the side, they were able to use the tube to pull up the arches, and they were able to construct the arches. And when they were deciding on the repair, somebody had the bright idea, actually, while we're doing this work, why not make it strong enough so we can have a road bridge? And that's what they did. So this arch was not only capable of carrying the railway, it was capable of carrying the road afterwards. Now, having built the arch, they were then able to cut the tube up, because it obviously supported the tube then. They cut the tubes in section and removed them that way. And this is in fact a section of the old tube which has been left on the side of the bridge as a memorial. And that lady, in fact, is Jean Baker, who is one of the founder members of the Menai Heritage Trust. And as to say, you can go there and have a look at that. And this, in fact, is the North Wales Coastal Path, which passes just by it. When you look at it, you can't believe, or I can't believe anyway, that it was strong enough to span 140 meters and support a train even in 1970 fully loaded with containers. But it did manage to do that, and it would have still been working today had it not been for the fire. And that's the bridge as it was completed. Now, the road section wasn't built immediately, but it was opened in 1980. So we were lucky, and now we had a second road crossing as well. I mentioned the towers before. You see how high they are. Now, initially, Stephenson wasn't 100% sure that the tubes would be strong enough to support his train. So he had proposals, or plan B, if you like, to put cables between the towers to give the tubes extra support. But they weren't needed, but he built the towers to that height anyway. Matter of interest, you see that is the Abutment Tower on the Anglesey side, and inside it's hollow, and it's what's referred to as the cathedral, because if you go inside it literally looks like a cathedral. It's limestone from Penman Quarry on the outside, but inside there's brick arches and is all supported. They wanted the limestone on the outside because of weathering, but on the inside there was no problem with weathering, and they were able to do it all in brickwork. And the bricks were actually manufactured on site, and you can see the base of the tower isn't much higher than the water level, so the inside of that tower is about 80 foot high, and it's quite a remarkable structure, and it's hollow. They did really know what they were doing. It's hollow for a few reasons. The amount of material required to fill that would have been tremendous, but not only that, if it was solid, then the weight of material would have been heavy and the ground may not have been able to support it. And also you have the problem of effectively the bottom of the tower would have been retaining walls, which so they would have had been substantial. So building the cathedral, as is known, was a good idea, and in fact it was a major feat in itself, purely just having the plant on site just to produce the bricks. So given the due, the Victorians went too bad. This is another view of the bridge. This is the main waterway. You see that is the Britannia Tower, and the strait looks nice and wide there and looks as if you can navigate all over the place, but it's very misleading. This marker here is what is known as Swelley's Rock. This is the worst, most treacherous part of the strait, because you've got this rock underneath, which you obviously have to be very much aware of when navigating. Now you see there's a white line there. Well, there's another reef there, and there's another one just by, so you really need to keep clear. If you're ever navigating the strait, keep clear of that side. Just matter of interest, you see there's an island on there. It's actually got a house on it. It's about a quarter of a mile away from the bridge, and there's a fish trap there till today, and there's many fish traps on the straits, and some of them go back to Roman times. Now, nearly finished now. We are very fortunate this part of the world in having two iconic structures, the Menai Bridge and the Britannia Bridge, which are also very photogenic. Now, if I had a penny for every time somebody has photographed these bridges, I would be a very rich man. You can see Britannia Bridge behind it over there, and there's another one of the Menai Bridge, and another photograph looking into the setting sun. Somebody's been very clever there in that they've located the island, positioned themselves so the island looks as if it's in the middle of the arch. So there is a classic photograph which many people take of when it's very calm water. You actually have the reflection of the arch there, and that is a very popular photograph that people take. Just one more slide. This is the land tower on the looking towards Anglesey. And you may have heard this talk about building a third bridge crossing. Now, as I mentioned before, the towers were built as Plan B for Stephenson, so they really are superfluous. There's no need of them. Now, when they built the bridge or rebuilt it in 1980, you've got the A55 either end, which is dual carriageway, but then you've got just two single carriageways over the bridge, and this causes a major bottleneck, as you can imagine, especially around in bank holidays, which is a shame, because had they actually thought about it at the time, they could have cantilevered either side of the bridge, this bridge, 2.5 meters either side. It would have been more than adequate to give you the two lanes. It would have meant they would have had to demolish or remove these towers, obviously, but they could have done it at the time. There's no way they can do it now, but it would have saved a third crossing. Hindsight is a wonderful thing. Thank you very much.